let us lay down few techniques that will help us identify the perfect square very easily. Okay, so to begin with, what I'm going to do is I'm going to write few numbers and I'll write down the squares of those. Okay, now we have few numbers here. They're not all the numbers, but just as an example. Now when you look at these numbers and you look at the unit place value of each one of these numbers, okay, so I'm putting them a red dot under those numbers. These are the numbers, they are at the unit place of the squares. Okay, what we notice specifically is that each one of those numbers, they are ending with a specific number in the end. Either it is 1 or 0. It's not 0 here, but let me write down a number 10 here. So 10 square is 100. So these numbers are ending with either a 0 or a 1, 4, 5, 6 or 9. So you will find that whenever you have a whole number, any whole number, small or large, and you square it, you will end up with one of these digits in the unit place value of the resultant figure that you obtain as a square. Okay, so that means my first trick is a perfect square will always end with one of these numbers in its unit place, these numbers. Okay, and at the same time there will be few numbers that a perfect square will never end with, right? It will never end with these numbers, which is 2 or 3 or 7 or 8. Okay, so we see this example right here in this very small table that we have. None of these end with either a 2 or a 3 or a 7 or 8. Okay, and the third technique I would also like to list down is that a perfect square will always end with the even number of zeros in its end. Okay, what exactly do we mean by that? So if I look at this number 10 only, okay, it ends with 100. 100 has two zeros in the end, right? That means even number, right? So if I were to take, let's say, so let me take one more number. Let's say I take 90 and I square it, I get 8100, correct? 8100 has two zeros, that is even number of zeros, correct? Even number. And for example, if I take 100 and I square it, I will get 10,000. 10,000 has four number of zeros, which is also even again, correct? So you can play with more numbers, but this will be a consistent result. You will find that any whole number that contains a zero, when you square it, you will always end up with a number that ends with even number of zeros. Okay, so with the help of these three properties, it will give us at least an initial litmus test of identifying whether a number could be or could not be a perfect square. And then we go from there. So let us take some examples to identify whether a number could be a perfect square or not. So I begin with 34. Okay, 34 is a number and I see that the unit value is 4, and it could be a perfect square because a perfect square should always end with either a 0 or 1 or 4 and so on, correct? So this could be one of those criteria that needs to be explored a little further. Okay, now let me take some numbers. Let's say I take 5. When I do 5 square, I get 25. Okay, and when I take 6 square, because 6 is right after 5, correct? It's the next whole number after 5. I get 36. Okay, and my number 34 falls in between 25 and 36. That means the square root of 34 has to be somewhere between 5 and 6. But if a number is between 5 and 6, that means it's not a whole number. It is a decimal or a fraction, something like that, correct? That means 34 is not a perfect square. Okay, so let's take our second example. In my second example, I have number 2287. I just took any large number at random. The only thing I have to look for in this number is what is at the unit place. It is 7. Okay, now we know that if any number that ends with 7, it cannot be a perfect square. That was our criteria number 2. Because we know that a perfect square will never end with 2 or 3 or 8 or 7 in its unit place. But this ends with 7, hence it is not a perfect square. So with the elimination round, I can stop here. I don't have to explore any further because this is the only answer I have to find. Identify whether it is a perfect square or not. Okay, Let's take one more example, the example number 3. In this case, I am taking this number 225. Okay. Now, this could be a perfect square because the number at the unit place is 5, and a perfect square might contain 5 at the unit place level, right? So that means I have to explore a little further. Is it really a perfect square or not? So the best way to find is find a square root of 225. Okay. Now think about this a little bit, that we are trying to find the square root of a 3-digit number. 1, 2, 3. There are 3 digits here, right? So that means the square root of this number has to be of 2-digit value. Otherwise, you cannot get a 3-digit number when you square a single-digit number, right? So it has to be 2 digits. And since it ends with 5, that means the digit at the unit place, it has to be 5. Otherwise, you cannot get a 5 here, right? So that is the known condition. And the only place we have to explore is what will be at tens place. So since it is a 2-digit number, we'll start with the lowest number here that could go, and that will be 1. Now if I try to find the square of this number, square of 15 is 225, and bingo, there you go. The square root of 225 is 15. Okay, and hence it is a perfect square. Yes, it is. So the idea is that when you're trying to find the perfect square or not, you may have to first follow the elimination strategy. The elimination strategy will tell you something like this. The example number 2, whether what ends with the unit place. Okay, with the elimination round, then if it passes through this criteria, then you explore what could be a square root of that number. You can take the direct squares of the whole numbers if it is a small number, or you might have to explore a little bit back and forth how to find a perfect square root, and then you identify whether a number is a perfect square or not. So there is no one unique method that will give you all the answers all the time. You might have to play with this strategy a little bit back and forth to identify a perfect square. But a lot of time the elimination round does help us a lot.